Hello again, class. Today we're going to talk about Unit 2, sketching. Purpose of sketching. A sketch is a freehand drawing used to describe the shape and size of an object. It is a means of quickly expressing an idea. So there's a few of us that are familiar with the back of an envelope for doing any kind of sketching or ideas that we might want to implement. We're going to take it just a little bit further though. We're going to use some graph paper. Now, the book talks about sketching arcs, circles, and ellipses and gives a great idea on how to use these points to be able to draw yourself a circle or an ellipse. I, however, am terrible at it. My circles look more like egg shapes and my ellipses look more like footballs for Stewie Griffin's head. Lucky for me, I make these. If you don't already have one, I suggest getting one. They're not too expensive and they're really handy, especially for drawing on blueprints. You can take these out and use the round soapstone to help mark out a circle on your mild steel using a center punch to the center of the hole. After you find the center of the hole, center punch, use this right in the middle of it and you soapstone to draw that circle. What I want to be able to focus on for this one is going to be the oblique and the isometric sketching. The oblique: to develop an oblique drawing, an orthographic view of the object is first drawn that best describes the shape and shows the most detail of the object. After completing the orthographic view, that's right here that we're familiar with, draw parallel lines, parallel receding lines at 45-degree angles from the corners of the view to develop the three-dimensional object like this, to develop the three-dimensional effect. Note that the lines are not usually shown for any part of the object that is not visible. The extent of the receding lines is about 1/2 the length that would be shown for an orthographic drawing. This is so that the sketch will appear to be true to the original form of the object. Or isometric sketching. To develop an isometric sketch, use isometric graph paper is preferable. An isometric sketch has all of its surfaces shown at 30-degree angles here. These get pretty busy. We're just going to stick with the oblique views for now, and that's what we're going to be implementing in the next few projects that we do. So, to give you an example of how to do those, we're going to do just what the book had said and start with our orthographic view. Here we're looking at the front view of this T-joint, right? So, to be able to get from this to this just takes a little bit of practice. What I like to do sometimes is I like to connect the dots. If I'm looking for about half, I start counting out the front of this. I got 1, 2, 3, 4, 5. Okay, so we're going to call it 3. If we want to go to half, I'm not going to go to 2.5. I'm going to go to 3. So remember that we're going to 45 degrees of an angle away from the orthographic view. So I'm going to go 1, 2, 3, and if it helps, connect some dots. And do some same here, 45-degree angle from corner to corner. 1, 2, 3. I've done something wrong. 1, 2, 3. Nope, I got it right. Okay. And we connect the dots. Also, if you're not sure if you got it right, you can take and go just a little bit longer. Just make the line really light. It's easy to erase. Just go way out beyond it. That one's easy enough. We're going to do the same up here. 45 degrees, that's one from this corner to that corner. 1, 2, 3. And the next one would be 1, 2, 3. Easy as connecting the dots. Apologize, I'm sticking my head in there. I forget there's a camera there sometimes. Alright, starting to take shape. Let's go back and erase what we don't need. here I can start to visualize. I'm going to have intersecting lines here. And if it helps, draw it out with little dots at each corners. Alright, now we're getting somewhere. Come on, stay focused here, camera. Again, we're just connecting these dots. 1, 2, 3. Or excuse me, 1, 2 for this one. 1, 2. Alright, now all we need is to define that. We've already got 2 points to go for reference. There we have it. Yeah, it looks alright. We can go back. Do a little heavier. Alright. It's that easy. Again, for circles, I like this guy right here. Say I want a 2-inch circle. Say I want a 1-inch circle. Here I'm already at 1 inch. That's not going to help me. This is just going to give me, this is getting me halfway there. I need to be able to, or this will double, excuse me. I need to get half the distance. If I want a 1-inch circle, I need to drop this down to a 1/2 inch. It's the best way about going that. Let's turn this down till we get, there's a 1/2 inch. You got to press down pretty hard into the point. You can't see that. Press down hard into the point, and then drag that around. I can do this and stay focused and in frame without getting in the way. For crying out loud, Jenkins. There we go. That's what erasers are for. 1-inch circle, yep. Take half the distance that we need to make our circle. And around we go. Looking good, 1 inch in every direction, fantastic. You can also use, we're just sketching, or we don't have tools like this, but if we happen to know the outside diameter of an object, if it happens to be correct, we can use that and trace around it just like we did when we were kids in kindergarten, right? We just trace around stuff. Oftentimes when I need to make a hole through something that I have to put a piece of conduit or a pipe or some kind of a pass through, I'll get the part that I need, stick it on there, take my soapstone or my Sharpie and mark around it. Cut to the inside of the line, or at least to the inside of the line, or the sides of the line, depending on if I'm going to be able to make that diameter, and cut my way through. We're going to do some of the same out on the lab floor. Now for our assignment, I've got this drawn up. Now, if you can't already see it, there's a mistake there that I'd like to point out. I was going to redo this, but then I thought maybe I'll just use this as a learning tool for what not to do. Now I've got all the information that I need. Everything's nice and sharp, but I've got this nice crease in here. I was not being careful, and I didn't handle it very well, and I put a nice big old fold in my paperwork. I want to stress that we do grade to professionalism, and that includes how well we handle this. It's not all, we don't want it all tore up. We don't want to have it pieced back together with Scotch tape. We don't want a bunch of dirty fingerprints all over it. We want it to look nice and clean. And to read out of our rubric on quality and professionalism, the drawing has no sloppiness. Every aspect of the drawing is sharp, clean and clear, paper is spotless, all drawing standards are met. So, yeah, don't do what David Don't did and get rough with your paper and put a big old crease down it. Alright, what not to do is out of the way. Let's talk about what we need to do. What we're going to be doing for this week in the lab and for the blueprint is we're going to have this square that we're going to use. We're going to be plasma art cutting. First, we're going to start off with a 6 by 6 inch 10 gauge sheet of material, and we're going to have you do a couple of different things. I want you to be able to take and cut two of those edges from that it was 6 by 6 and cut it down to 5 by 5. And we got the 5 by 5 for our overall length. We're going to use a straight edge. Probably not your rules from your tri-squares. I would suggest get a piece of flat bar or some other material, some scrap material to use as your guide when you're using your plasma art cut. And the way to measure where you need to put it is similar to how you need to make the circle. You want to measure from the outside edge to the center, and it would be the same for where we make our plasma art cut. Measure from the outside edge of the cup to the center to be able to make our mark. Measure that distance and draw a line, and I would suggest clamping whatever straight edge you're going to be using to hold it down before you take your plasma art cutter and you cut these two edges. But I want you to freehand these with the plasma art. Jig for these two. You can see here PAC for plasma art cut pointing to the edges of the material. But I want you to freehand this square hole and this 2-inch square hole and this 2-inch round. Now, how do we locate that? We find the center, what we want for this 2-inch round, and we know that we want this at 1.5 inches to the center and this at 1.5 inches to the center. Lay those out using your tri-square. We're going to center punch that hole there and use one of these tools. I have one you can borrow, and we'll lay that out. On this one, we'll just use our tri-squares using these dimensions and some soapstone or Sharpie to lay out these squares, this square. I don't need to see these center lines on your fabrication, but I do want to see something like this that is explained in chapter 1 on how to lay these out with our medium, short, medium on our lengths of our lines. Okay. Make sure that you have all these dimensions in here that we're looking for. That's 1.5 inches from the outside edge, 1.5 inches from this edge to the center. About 1/2 from here to there. 1/2 inch, 2.5. Same here, 1/2 inch, 2.5 to make our square on this 5 by 5 part. We'll also want to make sure that we're putting down what this material is, that it's a 10 gauge mild steel. Our scale is 1:1 for this project. Also, we want to write down week 3 lab fabrication, plasma art cut with your name on it. That'll be the assignment for the week for blueprint and for in the lab. If you have any questions, please let me know. Thanks.